All right, so welcome to the Gate Academy English channel. Very welcome to all of you, my dear students. Welcome to the Gate Academy English channel. So, beta, we are here with the live quiz session of Theory of Machine. So, lastly, we have completed the live quiz with timer sessions of fluid mechanics. Now, today I am going to start with the Theory of Machine live quiz with timer sessions. Okay. So, my dear, my name is Umar Shankar Tripathi, and I am a faculty of the Gate Academy. And today in this session, we are going to start with the first quiz session of Theory of Machine. Okay. So, those who are live on YouTube can tell me in the live chat session, are we ready for the quiz? Yes or no? Okay, so let's begin. So before I begin with this quiz, I want to share information. So there is a live Q&A session on GATE. See, students, we are having a lot of queries about how GATE preparation, how to prepare for GATE examination, and what paper to fill out. In this year, we have a choice to fill primary as well as a secondary paper. Okay, in what marks, what opportunities we get, how much rank branch specific we should have, and according to that, what opportunity we are going to have. Now, to answer all that question, our very good faculty, Santosh sir, is going to come live on 23rd August on English channel. And in this Q&A session, you can ask anything to him regarding this GATE examination. What are the benefits ahead of us? What are the opportunities? What are the form filling requirements? How to prepare? When to start prepare? So anything regarding the GATE examination in in this Q&A session, you guys can ask. So please save this date, 23rd August, Monday, English 1 p.m. Okay, okay, by Santosh sir. Okay, so be there live. This is going to be a very good session and very important session. So don't miss this session, my dear. Okay. Now, how to play this quiz? So as I see, some of you have already logged in. So I'll just briefly give you the procedure. So you can see a link there on the top of the screen in the red, right? So you can go on this link. Either you can use your laptop if you are watching me on the mobile. If you are watching me on the laptop, you can use a mobile for opening this link. And of course, you can open another window. If you are watching me on the mobile only, you can use the split screen option, and then you can open this link. Now, once you open this link, you will see a page. In that page, you just be seeing all these things, what is there on this screen. And after that, you will have to fill your name. No big registration process is required. Only you have to write your name. No email ID, no OTP, no message, nothing like that. Just your name is required. Now here I'll request you to write your real name. Okay, just don't write anything. Just write your name, real name, so that we can play this quiz nicely. Now in this quiz, we have no negative marking with any question. Okay, every question will be having some pointers assigned to that. Okay, and it will be displayed along with the question. Obviously, more tough the question is, more will be the points. Okay, and faster you answer, higher you score. So we know in competitive examination, not only we have to give the correct answer, but we have to give it in less time also. So here the pointers are assigned basic to your answer and in what time you answer. So if you answer in less time, you will be getting more marks. Okay, so let's start with the quiz. So I hope many of you must have already joined. If you have not joined, please go to the link. Please go to this link and join, so that we can start with this quiz. Please go to the link to join the quiz. Okay, so I see some students have already joined. Okay, very good. So let's begin with the quiz. So here we go with the first question. Here we go with the first question. So this is a numerical ability type question. This is a NAT numerical ability type question. And in this question, we have to fill the data. We know in GATE examination, we have three kind of question, that is MCQ, NAT, and recently they have added with MSQ, multi-select questions, in which more than one options are correct. Okay. In this NAT and MSQ question, remember the students, there is no negative marking in GATE examination also. Negative marking is there only in MCQ question. Okay, so we have to find the degree of freedom. Sometimes it is also called as mobility. Okay, so you can see a mechanism here. Okay, so if many of you have studied from me, you must have seen this question in the class also. Okay, very good question. Many questions it has been asked. So I am explaining. So this is the first quiz. That is why the first question has to be like a little bit simple so that all of us can answer. And as I see, many of you have already answered this question. Very good. Very good. Very nice. Okay, please solve for the degree of freedom. Please solve for the degree of freedom. In this, we have to find the degree of freedom, the mobility, what we call. Okay. You have to count the links, the number of links, number of binary joins, number of higher pairs, and the you can find the number of degree of freedom. Okay. So these kind of a questions to find the degree of freedom are asked a lot in the GATE examination. These are the very important kind of a question, and these kind of a question are usually asked in 1 marks in GATE examination. So I am hoping most of you must have answered it correctly. So if any one of you have not answered, answer it. When every one of you will answer it, then we can move ahead. Okay. So as we'll follow our usual quiz procedure, and after doing all the questions, we'll be having the solutions. We'll see what are the solutions of this question in the end of this session, nearly to the end of this session. All right. I am expecting right answer from all of you. So those still, if any one of you have not joined, you can see in the live chat box, the link is there. You just have to click on that link, a pop-up window will open, and there you have to register. For any student who have not yet joined the quiz can still join. Okay, still join. So we know, as we know, this is just a brush up to the concepts and see, let's want to see that if we can answer in the given time period or not. So the time is up. Let's see. Okay, so one wrong answer and 4 of you have given the right answer. So let's see how many of you have given the right answer. So Keshav has answered it correctly. Manisha, Gautam, Vikas, all 4 of you have answered it correctly. And Keshav have answered in the least time. So he has got the most marks. Okay. Chiranjeev, you were not able to solve this question, beta. Don't worry. Don't worry. We'll see the solution in the end of this session. Okay. So let's move to the next question. So let's see if we can do it or not. Okay. So this is a MCQ question. Multi-choice question. This is a MCQ question, that is a multi-choice question. So in these kind of a question, as we know, we have to select one option, which is the correct option. We have to select one correct option. So this is a 4-bar chain mechanism. I hope many of you can solve this question. So don't be in any hurry, beta. Please remember what we have taught you. Don't do the silly mistake. Try not to commit any silly mistake here. Please read the question properly. Okay. I'm expecting the right answer from everyone. Again, this is the first quiz session. Let's see how many of us can answer this. So basically, it is a question something related to what? Grashof law. Again, from this first chapter, you will see the numericals from the degree of freedom topic as well as the Grashof law. Mostly in GATE examination, they are asking the numericals from this topic. Right. Usual notation is there. We have 4 links. It is a 4-bar chain mechanism. If you remember, this is a simple mechanism in which all pairs are turning pair. Just giving you a brush up. This is having a degree of freedom of 1. Remember, this is having a degree of freedom of 1. And in any mechanism, we need to have a fixed link. So here the link which is fixed is having a length of 20 centimeter. Let's see if we can do it or not. So we know in a 4-bar chain mechanism, it can be a double crank mechanism, it could be a double rocker mechanism, it could be a crank rocker mechanism, or can't say. That is the fourth option. So basically, it is a Grashof law question. Try to remember the concept of the Grashof law, what he has told, or what is the law of Grashof. So I hope all of you must have answered this question. Let's see. Let's see how many of us have answered it correctly. Let's see how many of us. So time is going to get up. All right. So time is up, and I see. Okay, Keshav, Vikas, and Manisha. Three of you have given the right answer, and I think in this question Vikas have answered very quickly, so he have got the most point, followed by Keshav, followed by Manisha. Gautam, you were not able to give the right answer to this question. Chiranjit, you were also not able to give the right answer. Okay, so we'll see in what's in the solution that what went wrong. Okay, now coming to this question, let's see. This is a MSQ question, multi-select question. Multi-select question. So in multi-select question, my dear, you can opt more than one option, remember? So in this, you have to read all the statements, and then you will have to see which statement is correct and which is not correct. Okay. So out of these four options, you must choose the correct options. Okay. Which of these following are true? So multi-select questions are the new addition to GATE 2021 from GATE 2021, and it is followed by GATE 2022 as well. So in GATE 2022 also we are going to see some MSQ question. In MSQ question we can opt more than one options, unlike the MCQ question in which you can choose only one option. So here we can choose more than one option. Please go ahead. I'm hoping we can do it, all of you. So this with worth, there is a space is there, so not space is not necessary. It's overwriting. So with word quick return motion mechanism, it's an inversion of single slider crank mechanism in which crank is fixed. Second statement, a ball and socket joint has 3 degrees of freedom. Third option, Oldham coupling has 2 sliding and 2 turning pairs. Fourth option, a round bar in a round hole forms a turning pair. Now you have to select which one of the followings are correct, which are not. Okay, so you can choose more than one option. Now remember in MSQ question, as I keep saying it, so some students ask me this, sir, in MSQ question, if we answer a partially correct answer, like for say, out of these 4 options, all 4 were correct originally, but we have answered 3. So are we going to get some partial marks? No. Remember this, partial marking is not there. Either you are going to get the full mark or you are going to get 0 marks. No negative marking will be there in MSQ questions as well. So if you answered these questions wrongly in the examination, you won't be getting any negative marking. Understood, my dear? So I hope we can answer this. 20 seconds are left. So I think some of you are remaining to answer this question. I hope all of you must have answered it correctly. Very basic question it is. Let's see if we can answer it or not. So time is up. Let's see how many of us answered it correctly. So some of you have answered D also. Now let's see how many of you have correctly answered. So Vikas, very good. Now you are leading the chart. And Manisha, very nice, beta. You also have answered all the questions correctly, but You may improve in the time. Keshav, you were not able to answer this correctly. Gautam, again, you were not able to answer this correctly. Don't worry, beta. Don't worry. When we'll see the solution, we'll see what missed. Okay. Okay. Now coming up with the last question. So this is the last question in this quiz. Okay. This is the last question in this quiz. We have to find there is a crank and a slotted lever quick return motion mechanism. You see in the figure. Okay. And you have to find the quick return ratio. So let's see how many of us can find the quick return ratio. These kind of questions are very frequent in gate examination. We know quick return motion is used in shaper machines. What is the purpose of it? Remember that, beta? So basically, in a shaper machine, in the cutting stroke, it takes more time. But if that time will also be taken for the return stroke, there will be a loss of productivity. And being engineering students and the engineers, what is the role of an engineer? Is to reduce the cost, increase the profit. That means we have to increase the productivity. Okay. Now to improve the productivity, that return time in which tool is actually not doing anything or not performing any work or not being any use, not doing, and in the use I sense that basically in shaper machine the purpose is, thank you because I think you have watched my recorded sessions. So please solve the question, my dear, as well. Very nice. So some of you are still left to answer. I see some of you are still left to answer. So other than the Whitworth quick return, this is the crank and slotted lever quick return motion mechanism. Other than crank and slotted lever, we have Whitworth quick return motion mechanism. We have offset slider crank quick return motion mechanism. So in all the quick return mechanism, we have a quick return ratio. And generally, and if nothing is mentioned, I think we know in quick return ratio, whenever we ask, we have to write the time for the forward stroke to the time of the return stroke. Time to the forward stroke to time to the return stroke we have to write. So we have 15 more seconds left with this question, and this is the last question. After this question, we are going to have a quick discussion upon the questions. So this was the first quiz in this session of Theory of Machine. I hope you like this, and we'll see now. Time is up. So let's see how many of you have answered it correctly. Okay, so 4 of you have answered it correctly. So Vikas, very nice, beta. Gautam, you have also answered it correctly. So Vikas is leading with 378 points. Very nice, beta. Very nice. Congratulations to you. And Manisha also have given answers to all the questions correctly. Very nice, beta. Claps for you as well. Okay, so basically this quiz, it's the purpose of this quiz is basically to see and to give you a check on your preparation. That's it. Okay, that's it. Okay, so Keshav, you have answered 3 questions correctly. 1 question you were not able to, and Gautam, you were not able to answer 2 questions correctly. Right. So we'll see the solutions of these questions now. We'll see the solutions to this question now. So this was the first quiz. This was the first quiz in this session. So I see. Okay, so can we see the screen now, beta? Okay, so we can see, I guess, the OneNote now. Yes or no? Okay, some sort of problem is there. Okay, okay, just one moment. Huh? All right. Now I think you can see the screen, the OneNote. Yes. Yes. Okay. Now this was the first question, my dear. Usually I give this question in the classes also. So we know the degree of freedom we can find by using the great Kuchback equations. That is 3L minus 1 minus 2J minus H. So we have this L is the number of links. So let's just count the number of links. So we have 1, this whole is 2, this whole is 3, 4, 5, 6, 7, and don't forget about the slider, that is 8. So we have number of links as 8. Okay. How many joins we have? So this is a binary join. Two links are getting connected. This is a binary join. Two links are getting connected. One binary here, one binary here, one binary here, one binary here, one binary at this point, one binary at this point, one binary between 3 and 8, and one binary between 1 and 8. Don't forget to take care of the sliding pair, my dear. Okay, don't forget to take care of the sliding pair. Okay, so how many binary joins we got? 3, 3, 3, 6, 9, and 10. So binary joins is 10. So if I, and H is 0. So if I put it here, I'll be getting F is equal to 1. Degree of freedom is 1. Understood, beta? Any doubt you may ask me in the live chat. Okay, now coming to the second question, my dear. So the answer to this question is double rocker mechanism. See, sometimes what happens, what we come to understand from it, we see the shortest link is fixed. So, sir, it should be a double crank mechanism. But what I keep telling you guys while I teach the subject, that don't forget to check for the Grashof law. Okay. Now, what does Grashof law says? S plus L must be less than equal to P plus Q. Okay. Now, the shortest link and the longest link is 80, and P plus Q is S plus L is equal to 80, and P plus Q is 70. So as you see here, Grashof law is not satisfied. Grashof's law is not satisfied. Okay, normally students directly go to see which link is fixed to check with how many cranks we got. But when Grashof law is not satisfied, you fix any link, you are not going to get, you are not going to get this any crank in your mechanism. Okay, so only you can get the double crank or crank mechanism when Grashof law is satisfied. Okay, so when Grashof law is not satisfied, you cannot get any crank. So the answer to this question is double rocker mechanism. I hope it is clear to all of you. Feel free to ask me if there is a doubt. Now coming to the fourth statement. So this is a theoretical statement. So with what quick return motion mechanism is an inversion of single slider crank mechanism in which the crank is fixed. So very true, no? Isn't it? Yes, sir. Okay. We know with what quick return mechanism is an inversion of single slider crank mechanism in which crank is fixed. Very good, because okay, crank is fixed. Now, a ball and socket joint has 3 degrees of freedom. So we know ball and socket joint is a spherical pair which has 3 degrees of freedom, like our shoulders have. In our shoulder, we have the ball and socket joint like this. Na? This is the ball and socket joint. So we can have the 3-dimensional rotation to our shoulder. So this is a spherical pair which have 3 degrees of freedom. Now, Oldham coupling is an example of double slider crank mechanism. So in double slider crank mechanism, we very well know in double slider crank mechanism, we very well know that we have 2 turning pairs and 2 sliding pairs. Now a round bar in round hole forms a turning pair. No. So basically, I think some of you got confused with this. So my dear, as I keep telling you, so if there is a round bar in a round hole, basically it can rotate and as well as reciprocate. Okay, so this is an unconstrained motion example. This is an example of unconstrained. Okay, so in this, sliding and turning both are together. So we can't say it is a turning pair, right, beta? We can't say it is a turning pair. Okay, so the fourth option was incorrect. So the answer to this question was A, B, and C. I hope it is fine to you. Now coming to the last question, for the crank and slotted lever quick return motion mechanism shown in the figure, the quick return ratio is, so we have in this question, length of the crank This is the length of the connecting rod. This is the length of the crank. This is the length of the connecting rod. So first of all, we need to find the alpha. Shrikant, it is not a turning pair. It doesn't form a constraint motion. So we talk about this pairing thing when the motion is constrained, right? Isn't it? Yes or no? So it is not forming a constrained motion. So it is not in the category of the pairs that we have seen. Okay. Okay. So now we know the quick return ratio is beta by alpha beta. Quick return ratio is beta by alpha. And we very well know that cos alpha is the length of the crank to length of the connecting rod. Right, my dear? Length of the crank to length of the connecting rod. So length of the crank is 5, length of the connecting rod is 10. So we have alpha is equal to 60 degree. We have alpha is equal to, sorry, alpha by 2 it is. So alpha by 2 is equal to 60 degrees. So alpha is 120. We know alpha plus beta is 360. So beta then will be equal to 240. So the ratio of beta by alpha, that is 240 by 120, is equal to 2. So the answer to this question is 2. Okay. Any doubt in this question, my dear? We know this formula, right? In crank and slotted quick return motion mechanism. Please answer me yes or no. Is it fine, beta? Very good. So that will be all for this session, my dear. That will be all for this session. And I hope you guys like this quiz and enjoyed it. So basically, we are going to have 4 more quizzes of theory of machine, and in the same pattern to fluid mechanics, we'll try to cover as many as topic as possible. Okay, so don't forget to like and subscribe the channel. Okay, if you have not done that till yet, so please like the session, please like the channel, subscribe for it, and share this amongst your friend also, so that many students can join and can get benefited. So with this, thank you very much. Thanks a lot to all of you, and we'll see you with the next quiz of theory of machine. And don't forget to join the Q&A session, as I have informed you in the starting of this session. So thank you very much, and we'll see you in the next session.